Have you ever wondered if we could journey beyond our solar system? Could we reach the nearest star systems within our lifetime? Welcome to the world of interstellar missions, a field that's sparking immense curiosity and hope. As we stand at the precipice of the unknown, the limitations of our current space exploration capabilities are becoming increasingly apparent. We've been charting our celestial neighborhood, our very own solar system, for decades. But what lies beyond? What if we could traverse the vast cosmic distances to Alpha Centauri, Proxima Centauri, or even farther star systems? This is where interstellar missions come into play. These aren't just the stuff of science fiction anymore. The growing interest in this field is pushing the boundaries of human imagination and technological prowess. While the idea may seem far-fetched, the evolution of propulsion systems brings us closer to making this dream a reality. This, dear listeners, is where our interstellar journey begins. Journeying to the stars is no easy feat. It requires an efficient propulsion system, the heart of any space mission. In the early days of space exploration, the propulsion systems we used were quite primitive compared to what's being developed today. We began with chemical rockets. These giants of engineering were the trailblazers of space exploration. They were responsible for the first steps we took outside our own planet. The Saturn V, the rocket that propelled the Apollo missions to the moon, is a prime example. Fueled by a combination of kerosene and liquid oxygen, this behemoth stood over 300 feet tall. It was capable of generating a staggering 7.5 million pounds of thrust, enough to break free from Earth's gravitational pull. Chemical rockets were our first ticket to the stars. They took us to the moon, they launched our satellites, and they sent probes to the far reaches of our solar system. But they were not without their flaws. Chemical rockets are incredibly inefficient. They burn through their fuel at an alarming rate, making them unsuitable for long-distance travel. They're also incredibly heavy, which means a significant portion of their energy is used simply to lift their own weight. Another early propulsion system was the ion drive. This system works by electrically charging atoms and shooting them out the back of the spacecraft at high speeds. The result is a slow but steady push that can keep a spacecraft moving for years. However, ion drives are slow to accelerate and require a lot of power to operate, making them less than ideal for manned missions. These early systems were revolutionary, but they had their limitations. They were neither fast nor efficient enough for interstellar travel. But the quest for the stars did not end there. The dream of reaching other star systems sparked a revolution in propulsion technology, leading to the development of more advanced systems that we will explore in the next scene. As our ambitions grew, so did the need for more advanced propulsion systems. With our eyes set on the stars beyond our solar system, it became clear that traditional propulsion methods would not cut it. They were too slow, too inefficient, and too resource-intensive for the vast distances of interstellar space. Enter the dawn of advanced propulsion systems, a new era of space exploration driven by innovation and the relentless pursuit of the unknown. First, let's talk about ion drives. These aren't your typical rocket engines. Instead of burning fuel to create a forceful expulsion of gas, an ion drive works on the principle of electrostatics. It uses electricity to ionize a propellant like xenon, creating charged particles. These ions are then accelerated out of the engine using magnetic fields, propelling the spacecraft forward. The thrust is gentle but continuous, and over time, an ion drive can reach much higher speeds than a traditional rocket, using far less propellant. It's a bit like the tortoise in the famous fable. Slow and steady wins the race. But what if we want more power? That's where nuclear thermal propulsion comes in. Here, a nuclear reactor is used to heat a propellant, typically hydrogen, to extremely high temperatures. The hot gas is then expelled through a nozzle, providing thrust. This system has the potential to be twice as efficient as chemical rockets, and it could significantly reduce the travel time for interstellar missions. Imagine, instead of a journey to Mars taking 6 to 9 months, we could get there in just 3. These advanced propulsion systems have revolutionized the way we think about space travel. They've allowed us to dream bigger, to envision journeys to distant star systems, and to contemplate the very real possibility of becoming an interstellar species. But as we pushed the boundaries of what's possible, we realized we needed something even more groundbreaking. These advanced systems brought us closer to the stars, but we needed something even more revolutionary. Enter the Breakthrough Starshot project, an ambitious plan to reach the nearest star system, Alpha Centauri, within a few decades. This is not your regular space exploration mission. It's a project with the audacious aim of sending a fleet of tiny, lightweight spacecraft to our neighboring star system. The concept of Breakthrough Starshot is a fascinating one. It builds on the idea of using laser-powered propulsion to propel these tiny spacecraft. The plan is to use a massive array of ground-based lasers to shoot beams of light at an ultralight sail attached to the spacecraft. This light pressure then provides the thrust needed to accelerate the spacecraft to phenomenal speeds, potentially up to 20% the speed of light. The advantages of this system are numerous. First, it's fast. If successful, the journey to Alpha Centauri, which would take tens of thousands of years with conventional propulsion, could be done in a mere 2 decades. Secondly, it's energy efficient. The power for propulsion comes from lasers on Earth, meaning the spacecraft itself doesn't need to carry fuel, significantly reducing its weight and size. However, such an ambitious project doesn't come without its fair share of challenges. The technology involved is cutting-edge and unproven at this scale. The spacecraft must survive the harsh conditions of interstellar space, including cosmic radiation and tiny dust particles that could cause significant damage at high speeds. And then there's the small matter of slowing down once it reaches Alpha Centauri, which is a problem the project is still grappling with. The Breakthrough Starshot project is a testament to our relentless pursuit of knowledge and exploration. It's a bold vision and a new hope for interstellar travel. It's a project that dares to dream big and challenge the impossible. But with so many hurdles to overcome, the question lingers. The Breakthrough Starshot project represents a giant leap towards interstellar travel. But can it deliver on its promises? Only time will tell. So, what does the future hold for interstellar travel? As we look to the stars and dream of journeys beyond our solar system, the role of propulsion technology becomes increasingly significant. The current pace of technological advancement paints a promising picture for the future of interstellar travel. Propulsion technology is the driving force of space exploration. It's the engine that will power our spacecraft to the furthest reaches of the cosmos. In the future, we can expect to see a variety of new and innovative propulsion technologies, each with their unique advantages and capabilities. One potential game-changer is the concept of laser-powered propulsion. This revolutionary idea, as proposed by the Breakthrough Starshot project, plans to send ultralight spacecraft to the nearest star system, Alpha Centauri, within a few decades. By harnessing the power of concentrated light, these spacecraft could reach speeds unimaginable with today's propulsion systems. But the future of interstellar travel isn't just about speed, it's also about efficiency. Advanced propulsion systems such as ion drives and nuclear thermal propulsion are being studied for their potential to provide faster and more efficient deep space travel. These technologies could enable us to explore distant star systems with less fuel and fewer resources, making interstellar travel more sustainable and practical. The importance of continued research and innovation in this field cannot be overstated. Each new discovery, each technological breakthrough, brings us one step closer to making interstellar travel a reality. It's a journey filled with challenges, but the potential rewards are immense. Just imagine, future generations may witness the first human steps on an exoplanet, or the discovery of extraterrestrial life. These are the dreams that fuel our quest for advanced propulsion technology, and it's these dreams that will guide us into the future. Interstellar travel presents us with many challenges, but with every technological advance, we move one step closer to the stars. Today, we've journeyed through the evolution of propulsion systems and the promise of interstellar travel. We started with the early days when the idea of reaching beyond our own solar system was just a dream in the minds of science fiction writers and visionary scientists. We've explored the dawn of advanced propulsion systems like ion drives and nuclear thermal propulsion, which have opened up new possibilities for faster and more efficient deep space travel. We've looked at the future of interstellar travel as projects like Breakthrough Starshot aim to propel ultralight spacecraft to Alpha Centauri, our nearest star system, within just a few decades. This is an exciting time in the history of space exploration, as we push the boundaries of what's possible and venture into the unknown. As we stand on the cusp of a new era in space exploration, we can only wonder, what's next? Stay tuned to the Truth Chronicles for more exciting insights into our universe.